For this video covering the second half of Chapter 5, I'll discuss what conditional execution is, how that looks in a script, really the two different ways that we can type it up, whether it's chained conditional or nested conditionals, and then tell you about how to get input from a script user via the keyboard, kind of typed input. Both of these things together will equip you to be able to answer the questions in the second assigned lab, which is up on Blackboard. So going back to the analogy, a program is like a recipe. Recipes based on kind of different ingredients that you might have on hand, different equipment, I guess, and different goals. What kind of cookies do you want to make? And maybe even different conditions. So kind of, are you at high elevation or whatnot? You might need to tweak a given recipe to get the desired best outcome. And computer programs, you might think of them as recipes, as working on inputs instead of just ingredients, and kind of rendering outputs same way according to a set of prescribed statements. The interpreter analyzes what you type, what you include in your script very precisely, very literally. But it also needs to be flexible to different inputs, whether those vary slightly or more substantially, and different outputs. So a program is more useful if it can be more flexible in its application. But one of the ways that's built into Python and other language structures to allow for this flexibility is called conditional execution. So back to a recipe, you might think of conditional execution as giving options based on common or typical anticipated ingredients. So if you're baking something with whole wheat flour, use 4 cups. But if you're just using white flour, use 3.5. Could have to do with the units. So if your oven tracks temperature and measures temperature in degrees Fahrenheit, bake at 425 degrees, but in Celsius, use 220. Conditional execution in our computer programs, it has kind of 2 dimensions to it. One are the conditions themselves. So these conditions are checked to see if they are true or false. And if they are true, the linked related statement is going to be executed. If not, that statement is not executed. So in Python, the token, like what we type, the little bit of text to initiate conditional execution is if. We have a line, begins if, followed by the condition, followed by a colon. So if the condition that follows if, that precedes the colon, is true, then on the subsequent line, indented 1 tab, the statement will be executed. And if the condition is false, then that statement will not be executed, and the flow of execution just continues down to the next line. So what we'll do, we can type up this script, x equals 5. If x is greater than 0, print x is positive, y equals -5. If y is less than 0, print y is negative. So I said in a script, so I'll open up a new file, just save it as conditional And what do we have? X equals 5 if x is less than or is greater than 0, colon, print, and I'm going to use parentheses now, because it's Python 3 session I'm in, print x, comma, quote, because I want to type some words in a string, is a positive number. We can just, I saved, we can run this. I don't want it to be the entire screen. Run the script. There we go. 5 is a positive number. And if we want to handle negative numbers, we can add that second part, y equals negative 5. If y is less than 0, print y, comma, space, quote, is a negative number. There we go. Let's save that now. Run it again. So this is kind of the beginning of conditional execution. If we change x from 5 to negative 10, we change y, well, we'll keep y for now. And run that. So only the line negative 5 is a negative number is going to be executed. So if I assign a value of negative 10 to x, then this condition is not true, it's false. And because it's false, this statement is not executed at all. Now, if you just have an if statement, and this kind of these 3 lines at the top, really, they're the same thing I just did manually. If x is negative 5, then x is not greater than 0. That condition is false. So this statement is not executed. And when I just ran that in idle, nothing happened. Now you might not want nothing at all to happen. You might want an alternative specific thing to happen. And in order for that to work, there's the built-in if-else structure. So else, this token, is followed immediately by a colon. There's no condition for else in that line. It always would follow this little block beginning with if, and it says to the interpreter, instead of doing nothing if this condition is false, instead execute this line, this statement. Print x is negative. So if we go back, eliminate that y bit, and just type else, print x is negative. So now our x equals negative 10 is handled in a way that's informative for someone who's using the code. So as I said, conditional execution makes your scripts more adaptable and therefore more useful. So they can take in a range of inputs, provide different outputs by executing slightly different number or selection of statements based on what those inputs are. So here's a task in the red text. In a script, define a function that takes one parameter. The function should check if a number is odd or even and print the number is odd or even so that it correctly categorizes number passed as an argument. So I'll open up a new file. Save that as conditional2. And what do? If we're going to define a function, we begin that line DEF space and the name. Well, no name is really given. Call it odd or even. And then followed by the parenthesis, it's going to take one parameter, we'll call it number. Add a colon, hit enter, brings us down here. So in the part 1 slides of this, I kind of referenced again the mathematical operator of modulus. And that's kind of the name for it. You can also think of it as the percent sign because that's the character we use. And one of the examples, we go back, you can just scroll up. It's the same PowerPoint deck. Here we go, the modulus operator. So one of the application areas was test if x is an odd or even number. So x modulus 2 equals 0. That will be true if x is even. If x divided by 2 has no remainder, then x is going to be even. If it has a remainder of 1, then x is odd. We can use that in our program. Because I called this parameter number, I'm going to type out number as the variable, as the operand of that modulus. 2, that's going to be the same. And then double equals sign 0. So that's either going to be true or false. In our conditional execution, that is the condition. So I'm going to type before it the token if space, then the condition, follow that with a colon. And then on this next line, which is double indented, is going to be the statement that executes if we have an even number. If the remainder from dividing the number by 2 is going to be 0, we want a print statement. We'll start off with number is even. And then in the case that the remainder is not 0, else print number is odd. Then below, we're going to want to call the function. We'll call it on a few numbers. Call it on 2, which we know to be an even number, odd or even. And we'll call it on 3, which we know to be an odd number. Let's see how that works. Invalid syntax. I did not close my parentheses for the print statement. There we go. 2 is even, 3 is odd. So we define a function, and within that function have just a simple branch. If the argument that's passed as the parameter number is divisible by 2 with no remainder, we print the number, the value of the number is even. But if not, we print is odd. And get back to where we need to be. So on this next slide, just shows how alternatively we could write a function that tests whether an input number, here the parameter name is x, is divisible by 5. And that can be any integer. You just vary the operand after the modulus. And we wouldn't use even and odd. I mean, we have those words to describe whether or not numbers are divisible by 2. There aren't kind of equivalent numbers for other integers. But similar structure, if you just want to vary the denominator, I guess. You just change the operand after the modulus. Another token you can use in setting up conditionals is elif. It's kind of a blend of the el from else and if. There we go. Elif can follow an if statement like an else, but offer a second or a different alternative, but alternative specific condition. So we remember that there's no condition assigned to else. It's basically what to do, kind of a specific statement to execute, but only if all of the other mentioned conditions are false. elif allows you to check whether or not another condition is true. So if x is less than y, print x is less than y. If x greater than y is true, print x, comma, is greater than y. Else, print x and y are equal. And this kind of, if we go back and check the script here, x is greater than 0, print x is a positive number, else print x is negative. If we run this code with x equal to 0, it's telling us 0 is negative. So this script might benefit from an elif line. And what will we do? Elif x equals 0, not a single equal sign. In Python, that's what we use to assign a value to a variable. In our Boolean expressions that will reduce to either true or false, be evaluated to true or false, we use double equal sign. And in that case, print x is 0. So now we save and run, it accounts for 0. And this slide is also called chained conditionals. So if you use elif, when you type out these different alternatives, these different branches they're called, they're all kind of vertically aligned here at the same kind of inset or tab level. And read right down. This is one way to structure the checking of multiple conditions. Kind of up here in the right corner, the willow tree, you can think of the flow chart for this alternative conditional execution as kind of looking like cascading willow. So starting at the top, kind of going out and down. So choice A, really condition, the first condition is evaluated, and if true, this statement is going to be executed. And if it gets executed, the rest of the block of text is skipped. It's not interpreted. It just moves on to the line of code that would be after this else. But if that condition, choice equals A, is false, then the second mentioned condition is evaluated. And if that's true, subsequent lines are skipped. If false, the third choice here is presented. And if that's false, there's no other condition, end with an else, just print invalid choice. So this example also shows that you can have multiple elif conditions. You begin with if, you're followed by elif. And if you don't need anything to happen, if none of these are true, you do not need to end with an else there. So nested conditionals is a way of accomplishing the same kind of condition checks, conditional execution, but by structuring your code in a different way, and in a way that does not use elif. Instead, you nest an alternative if-else kind of binary either or check after the initial else. So you can see this first if x is the same as y, that condition is going to be evaluated. And if it's true, something will be printed. X and y are equal. Else, if they're not equal, there's an if statement. If x is less than y, print that. Else, print x is greater than y. So this bit of code is evaluated in the same way as this bottom chunk. They both work the same way in terms of how they're being interpreted, what the computer is doing. I'm kind of flipping back and forth here between nested and chained. The benefit for using chained conditionals is simply on the human end, on our end. Kind of it gives us fewer lines of code, which isn't so apparent if there's only one or two branches, but if there are 4 or 5, something like that, sorry, you do get a little bit of compression, fewer lines, using chained conditionals. And all of the tokens here, if, elif, 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 else, are vertically aligned. They just line up. So it's a little bit easier to read as a person. But if for some reason you do prefer or you encounter nested conditionals, just know that they'll be interpreted in the same way. Code will still work. I'll mention here the return statement. I talked about how certain functions can return values that can be used as inputs to other functions. There, the return token is going to be followed by some variable name. Return, and by that I mean the characters RETURN, if you type that out without any variable, what it means is it just stops the execution of a function immediately. So here, if I were able to align this, it's a bit wrong. You might want to, so the return here would prevent the function from trying to calculate a logarithm for a negative number. So it just tests a condition. In this case, the condition is one that would lead to a runtime error for the function. So if the condition is true, this line is having a message be printed to the user so that they know they did something wrong. They tried to give an invalid input, and then also stops the function from trying to do something it can't. So if you just see return by itself, exits out of a function. And then finally, another thing that you'll need to use in the assignment, the lab, is taking input from a keyboard. So this is in the shell. The name of the function is different whether you're in a Python 2 session or Python 3. In Python 2, this built-in function is called raw_input. It takes as a parameter some bit of text to show the user as a prompt to have them understand what kind of an input they should type in. Whatever they type in will be assigned as a variable, as a value to the variable name here as a string. So this second example asks the user, how old are you? And if they type in 19, then that variable will initially be saved as a 2-character string, character 1, character 9. So if you want to give an answer like, oh, you will be this age next year, or any kind of value derived from that, you would want to convert it to a number value. So we'll take a look right here. You can run it in the same script. It doesn't really have anything to do with our conditional execution, but this is a Python 3 session. So we'll see. We'll do that example with age equals input, and then we'll need to type a string that gives the user information about what to type. So please type your age here. And then we can run a print statement, and we'll print age. So now if we run, you can see here, please type your age here, and a blinking cursor. 30, and we hit enter, then that's what gets printed back. So what if we want to say, we want to tell somebody their age in 5 years? Print age plus 5. Oh. Get another, please type your age here. And we get an error. Type error, can't convert int object to string. So whatever the user types, even if it's a number, is being stored as a string. Let's see, we can check that. Type age, run that. Print type age. Got to print that out. There we go, class string. So if we want to print out kind of a number that's derived from whatever the input is, I'll want to convert that age into an integer, plus 5. There we go. Got an output of 35.